Okay, now let's talk about spheres. They're a little different than pyramids, cylinders, and prisms and cones, so they get their own section. Right? So a sphere is like a ball, like the Earth is sort of a sphere. It's not a perfect sphere. Orange, same thing, ball. You know what a sphere is. So for the surface area of a sphere, here's a cool video you can watch that demonstrates it. And if we were in class and I could afford a bunch of oranges to buy, we would do this experiment. And I'll just describe it to you real quick, but I encourage you to watch it. It's just 2 minutes. But someone takes an orange and he traces out the largest circle in that orange and then peels the orange into a bunch of little pieces. Now the peel represents the surface area of a sphere. So if you haven't watched the video yet, I want you to think of how many circles do you think that represent the largest circle of the orange could he fill with the peel? In other words, how many areas of the circle does it take to complete the entire surface area of the sphere? If you want time to think, pause. So the answer is 4. Surface area of a sphere is 4 times the area of a circle. And that video linked right there does a good job of showing it. So I encourage you to watch it. So the formula we're going to use for surface area of a sphere is 4 pi r squared. Now another video, which is a little more complicated to explain, but I'll do my best, but I encourage you to watch it. It's also like a 2-minute video. The volume of the sphere has to do with pyramids. So if you imagine taking a sphere and dividing it from the inside into a bunch of little pyramids and added up all their volumes together by taking the volume of each individual pyramid, it would come out to 4/3 pi r cubed. Now I don't expect you to understand that simply by my 20-second explanation. So you should watch the video. It takes 2 minutes and it'll make sense. But for now, if you haven't yet, you could just use that formula. But definitely watch it if you haven't watched it yet. So let's find the surface area and volume of the sphere. Alright, it's given pretty clearly that the radius of the sphere is 6. So the surface area is going to be 4 pi r squared. So that's going to be 4 times 36, which is 144 pi. And there's no units here, but since it's a surface area, that would be in square units. Alright, so if that was 6 inches, the surface area would be 144 square inches. Now for the volume, we also just plug in the radius. So it's 4/3 pi r, which is 6 cubed. Now cubing something, 6 cubed, just means you multiply 6 by itself 3 times. So we end up getting 216 times 4 divided by 3 pi cubic units for the volume of the sphere, which we can simplify, and it comes out to 288 pi cubic units. Okay, it's important to remember or understand or think about that this is an area, so it's in square units. This is a volume, so it's in cubic units. So you don't really want to compare the two. It'd be like comparing your weight to your speed. It's just different units of measurement. Wouldn't really make sense. So sometimes you can have objects where the volume is a lower number than the area, but you don't really say something has a smaller volume than its area, because you just don't compare those quantities like that. Okay, from geography, you might be familiar with the term hemisphere, right? Eastern hemisphere, western hemisphere, cuts the globe in half. Above the equator is the northern hemisphere, below the equator is the southern hemisphere. It's just a half of a sphere. And another piece of vocab is that we call this top part of the circle, right here, the great circle. So let's look at a problem involving hemispheres. So find the surface area of the sphere given that the area of the great circle is 201.1. Now, I'm sure there's other ways to do this, but I'm about to show you kind of slick way to do it. Okay, so this circle right here has an area of 201.1 square inches. Area is equal to pi r squared. Now this circle has the same radius as this hemisphere. Now the surface area of a sphere is 4 pi r squared. So sometimes you don't have to solve for a variable if you already have a quantity that you need. For example, we already have pi r squared, and it's referenced right here. So instead of solving and plugging something in for r, we could plug that in for pi r squared. Now we are looking for half a hemisphere. So it makes sense to cut that in half. And we get the surface area is equal to 2 pi r squared. But if we cut a sphere in half, the surface area would only be what I'm highlighting in green. And we wouldn't be accounting for that blue circle on top. So you would have to add another pi r squared to account for the great circle. And you get 3 pi r squared. So since we already know pi r squared is 201.1, we could plug in 201.1 right here for pi r squared, and we get that our surface area is 603.3 square inches because it is a surface area.